Hello everyone, welcome to Amplify Learning. So today we'll be solving a problem from complex numbers, and this was a question from 2016 JEE Advanced. So here's the problem. Let a b belongs to real numbers and a square plus b square not equal to 0. Suppose s is equal to z belongs to c and z is equal to 1 by a plus ibt, where t belongs to real and t not equal to 0, where iota is equal to root over minus 1. If z is equal to x plus iy and z belongs to s, then xy lies on, and we have four different options. So first of all, option C and D, we'll check for that, because those are the most simplest ones, where we just take 0 for two of those variables, a or b. So we'll check that first. So let's start solving the problem. So here we have z equal to 1 by a plus ibt and also z equal to x plus iy. Now if b is equal to 0, we get z is equal to 1 by a, and when we compare it to x plus iy, we only have the real part, no imaginary part is there. So y will be equal to 0 and will be equal to 1 by a, right? So, and this point y equal to 0 and 1 by a, so clearly it lies on x-axis. So option C is correct. Okay, and now if a is equal to 0, okay, 1 by z, then z becomes z is equal to 1 by ibt, which is equal to multiplying by I in the numerator and denominator, we get minus I by bt. So we get the imaginary part. So this is completely imaginary and the real part is 0. So x becomes 0 and y becomes minus 1 by bt, and thus this clearly lies on y-axis. So option D is correct. Now for option A or B, right, we have to solve. So option D is correct, right? So for the third part, let's solve this one. Z is equal to 1 by a plus ibt, or we can basically we can multiply it by its conjugate, and we will get this a minus ibt by a square plus b square, a square plus b square t square, multiplying numerator and denominator by a minus ibt, which is basically the conjugate of this part, right? So and we can z is also equal to x plus iy. Now we have to find the locus of x and y. So we will solve this equation and we'll try to find out what is ax equal to and y equal to, and from that we will basically, t is the variable here which we need to solve for, and when we can equate t, we will get the locus with respect to a and b. We'll get x and y, right? So we will get the locus, and then we will understand which of the two options a or b is correct. So we take the real part and the imaginary part out. So x equal to a by a square plus b square t square, and y equal to minus bt by a square plus a square plus b square t square. So now we solve, we take this here, okay? So a square plus b square t square is equal to a by x. Simultaneously we multiply this with a, and we get this. Now we get a t square equal to a by x minus a square divided by b square from the x part, real part of the equation, and from the imaginary part of the equation we get a quadratic, right? So we solve it. We use the general formula for finding out the roots of the quadratic, that is t is equal to minus b plus minus root over b square minus 4a square b square y square by 2b square y. We are clearly getting this from minus b plus minus root over b square minus 4ac by 2a, right? That is the general formula for ax square plus bx plus c equal to 0. Okay, now solving this, what we can do, this is t square term and this is t term, so we can square this term and equate this. So that's what we have done. So we have squared this and equating this, we cancel out b square first from both sides of the equation. Now we have a by x minus a square in the LHS, and we have this term. Expanding this, we get this one in RHS. Now we can clearly see that 2 and b square, these are common here, so we obviously that gets cut out from the numerator and denominator, right? So we have 2b square in the numerator and 2b square in the denominator as well. So we have this one 1 minus plus root over 1 minus 4a square y square minus 2a square y square. We are keeping this minus plus because eventually we have to remove this root over as well. So to remove, and for removing this we can square, and when we square we will, whether it's minus or plus, when we square it we will have plus. So for that I am just keeping it, right? Okay, so now we multiply 2y square, we take 2y square to LHS and we multiply it, so we get 2y square a by x minus 2a square y square, right? And in this side we have 1 minus plus root over 1 minus 4a square y square minus 2a square y square. So we can cancel out 2a square y square from both sides of the equation, and we have this one, right? And now we have this square term, a root over term on RHS, so we will just square it, right, to remove the square, and then we can solve. So 4y to the power 4 a square by x square minus 4y square a by x plus 1 is equal to 1 minus 4a square y square. So we cancel out 1 and then we solve this equation, right? First of all, we have we can take 4a, I think 4y square a common, right? So we can take 4y square a common, right? And so basically we can divide it by 4y square a. So dividing it by 4y square a, we get y square a minus x plus a x square. Now we divide it by a, we get this equation, and you can see that we can transform this equation in the form of a square, certain square, right? So what we do, we multiply it by 2 and we divide this by 2. So we write it in this format: x square minus 2 into x into 1 by 2a. So this is basically equal to minus x by a, and then what we write, 1 by 2a whole square and minus 1 by 2a whole square. This is basically 0, we can add 0. So but then we have a square term in this, x square term in this format, right? This is basically x minus 1 by 2a whole square, right? And we take this to the right hand side and we get x minus 1 by 2a whole square plus y square is equal to 1 by 2a whole square. This is basically equation of a circle which has center at 1 by 2a comma 0 and has a radius equal to 1 by 2a. So which is option number A, correct? So that was it for today's series of solving a mathematics problem, and we'll be continuing this series, so stay tuned for the upcoming problems. And if you have any specific problems that you would like the solution of, you can comment down below. Thank you.
Thank you for watching. Do leave a like, and for more such educational content, subscribe.